Question 12. Prove that 1 minus cos 2 theta is equal to tan theta sine 2 theta. So part A, 1 minus cos 2 theta always equal to tan theta sine 2 theta. So I'm going to rewrite the right hand side, so sine theta over cos theta multiplied by 2 sine theta cos theta. We can see here that our cos thetas are going to cancel and we're left with 2 sine squared theta. Using double angle formula, we know that cos 2 theta is equal to 1 minus 2 sine squared theta. So therefore this is equal, if we rearrange it, to 1 minus cos 2 theta, and we've proved it. Part B, hence solve for negative pi over 2 is less than x is less than pi over 2. The equation sec squared x minus 5, 1 minus cos 2x is equal to 3 tan squared x sine 2x. Give any non-exact answer to 3 decimal places where appropriate. It's quite a tricky question here. So what we've got, sec squared x minus 5, 1 minus cos 2x is equal to 3 tan squared x sine 2x. Now it says hence, so that means using what we've just found. So if we look at the similarities between what we've got here and then what we've got here, what we can do is we can say that this is going to be 3 tan x lots of 1 minus 2 cos x, or 1 minus cos 2x, sorry. So if we then say that we've got sec squared x minus 5, 1 minus cos 2x, take away 3 tan x, 1 minus cos 2x is equal to 0, we can see that here we can actually factorise and say that we've got 1 minus cos 2x lots of sec squared x minus 5 minus 3 tan x is equal to 0. Using the identity that 1 add tan squared x is equal to sec squared x, what we can do is we can say that we've got 1 minus cos 2x, then we've got tan squared x add 1 minus 5 minus 3 tan x equals 0. So we've got 1 minus cos 2x, tan squared x minus 3 tan x minus 4 is equal to 0. Factorising the quadratic, we've got 1 minus cos 2x, tan x add 1, tan x minus 4 is equal to 0. So now we've got a few separate solutions. So we're looking between negative pi over 2 and positive pi over 2. So if we say that we've got cos 2x equals 1, and this, it would be between negative pi over 2 and positive pi over 2, but because it's 2x, it's between negative pi 2x and positive pi. So inversing that, we're going to get that 2x is equal to 0, and therefore x is equal to 0. If we've got tan x is equal to minus 1 between negative pi over 2 x and pi over 2, then we're going to get that x is going to be minus pi over 4, minus 45 degrees, and that is going to be our only solution. And then the final one is tan x equals 4 between negative pi over 2x and pi over 2, and by doing that we're going to get that x is equal to 1.33 radians. So our values, x is equal to 0, 1.33 and negative pi over 4.